For centuries, human civilization has grown outward across land. But today, the planet is quietly signaling its limits. Coastlines glow with megacities pressed tighter each year. Sea levels inch higher, storms grow stronger, and the space we depend on becomes increasingly fragile. Nowhere is this pressure more visible than in Japan, where dense urban life meets an unforgiving ocean and a shrinking margin for error. Yet beyond the crowded shore lies something vast, calm, and largely untouched. As the surface world struggles with climate risk and limited space, engineers have begun asking a radical question. What if cities no longer needed land at all? The idea isn't new. Visions of underwater living have existed for decades, but today, technology, materials, and energy systems have finally begun to catch up with imagination. By mapping the depths surrounding Japan and studying how the ocean itself moves, breathes, and generates power, a new blueprint has emerged. One not built on fantasy, but on physics, sustainability, and survival. At the center of this vision is a vertical city designed not to fight the ocean, but to live within it. This is the ocean spiral, a concept that challenges how we define a city, where we build it, and what the future of human habitation could become. The ocean spiral is not a single structure, but a vertical system engineered to span nearly 15 kilometers from the ocean's surface to the sea floor, functioning as one integrated city. At the top sits the Blue Garden, a floating habitat designed for human life, while below it, the Infraspiral descends through layers of increasing pressure, connecting the surface to the earth, factory anchored deep on the seabed. Each section exists for a distinct purpose, yet none can function alone. As the structure moves downward, it passes through dramatically different ocean environments, where pressure, temperature, and density change continuously, conditions that shape every engineering decision. When compared to the tallest skyscrapers ever built, the scale of this system becomes clear. Ocean spiral is not tall by city standards, it is deep by planetary standards. To manage this complexity, the entire city is designed as a modular framework, broken into repeatable segments that can be fabricated, tested, and assembled independently. Digital blueprints allow engineers to simulate ocean currents flowing naturally around the structure, while stress analysis models map how forces shift under immense pressure. Advanced computational design tools annotate every section with material limits, load tolerances, and depth ratings, turning the ocean itself into a design parameter rather than an obstacle. Cost models and development timelines remain projections, not promises, clearly marking the project as being in its conceptual development phase. Yet with the master plan defined, tension now turns upward to the surface, where human life would begin, inside a structure designed to float, adapt, and survive in open ocean conditions. At the surface of the ocean spiral begins. Not as a tower, but as a sphere, an immense floating structure designed to sit partially submerged at the waterline. Measuring roughly 500 meters across, the Blue Garden is engineered to house human life while remaining in constant balance with the sea around it. Inside, the sphere is largely hollow, organized around a central vertical core, where a 75-story tower would rise, forming the structural and functional heart of the habitat. Rather than relying on conventional construction, the outer shell is designed to be assembled by autonomous systems, locking curved panels together to create a pressure-resistant enclosure. Its most critical feature, however, is buoyancy. In calm conditions, the sphere floats higher, allowing sunlight to enter and illuminate the interior. When storms approach, the structure is designed to lower itself slightly beneath the surface, sitting below the most violent wave energy and reducing stress during typhoons. Within the shell, residential, commercial, and communal zones are planned as layered environments connected by vertical circulation paths, all carefully arranged to support a projected population of around 5,000 residents. The Blue Garden is not imagined as a luxury escape, but as a functional surface anchor, one that adapts to the ocean's behavior rather than resisting it. And beneath this floating habitat, the true scale of the system begins. As the city transitions downward into the spiral that connects human life to the depths below, connecting the surface habitat to the ocean floor is the Infraspiral, a vertical lifeline designed to move energy, water, resources, and data through nearly 15 kilometers of open ocean. Rather than a solid column, the spiral is conceived as a segmented ribbon, assembled piece by autonomous systems and reinforced to withstand increasing pressure with depth. Inside, multiple channels run in parallel, each dedicated to a specific function, transforming the structure into a living conduit rather than a simple support. The spiral's most critical role is energy generation, powered by ocean thermal energy conversion, or OTEC, by drawing in warm surface water and cold deep-sea water simultaneously. The system exploits their natural temperature difference to generate continuous carbon-free electricity. That energy then travels upward through the spiral, supplying power to the surface habitat without relying on sunlight or wind. Alongside electricity, fresh water produced through desalination and essential supplies move through protected internal pathways, isolated from the harsh external environment. As the spiral descends, sensors constantly monitor pressure, vibration, and structural stress, allowing the system to adapt dynamically to changing ocean conditions. With each meter downward, light fades and pressure intensifies. Yet the spiral continues uninterrupted, linking human life above two industrial systems below. And at the very end of this descent, where the ocean floor begins, the city's deepest and most critical component awaits. For ocean spiral to function as a true city, it cannot rely on external supply. Shenzhen must first prove that it can sustain itself. That process begins not underwater, but in laboratories, coastal test sites, and offshore platforms where engineers are already validating the core systems piece by piece. Small-scale ocean thermal energy conversion units are tested by drawing warm surface water and cold deep-sea water simultaneously, measuring whether stable power can be generated continuously over time. Turbines are exposed to saltwater corrosion, pressure, and long-term wear to ensure reliability in harsh marine conditions. In parallel, pilot desalination plants convert seawater into drinkable freshwater, with every output tested for safety and efficiency. Food systems are developed through controlled aquaponics and marine farming experiments, where fish, plants, and microorganisms are studied as part of closed-loop ecosystems. None of these systems are assumed to work automatically. They are stress-tested, simulated, and monitored under failure scenarios to understand their limits. Digital integration models then combine power, water, and food into a single operating framework, revealing how fluctuations in one system affect the others. Only after months or years of uninterrupted testing can a scaled habitat module operate autonomously, proving whether true self-sustainability is achievable. This phase does not mark construction, it marks readiness. Because before a city can exist underwater, it must first survive on its own. At the very bottom of the ocean, spiral lies its most complex and least visible component, the Earth Factory. Designed to operate where pressure is extreme and human presence is impossible. Long before any permanent structure could exist here, engineers began by studying the sea floor itself, using remotely operated vehicles and sonar mapping to identify stable terrain and geological risks. Prototype modules are then subjected to crushing pressures inside specialized test chambers, validating whether materials and seals can survive years at depth. Rather than constructing a single massive base, the Earth Factory is envisioned as a modular system, allowing sections to be deployed gradually and expanded only when proven safe. Robotic drilling technologies are tested to extract rare earth minerals from simulated seabed materials, while laboratory analysis determines whether recovery can be done efficiently and responsibly. At the same time, experimental bioreactors explore how microorganisms can capture carbon dioxide and convert it into methane, transforming waste into usable fuel. One of the most radical concepts relies not on machinery, but on physics itself, using natural deep-sea pressure to drive desalination without electrical pumping. All of these systems are brought together digitally, where simulations reveal how mining, energy production, water generation, and environmental protection must operate as a single coordinated network. Throughout development, continuous monitoring ensures that marine ecosystems remain protected, placing safeguards alongside ambition. The Earth Factory is not designed to dominate the ocean floor, but to coexist with it, turning depth, pressure, and isolation into advantages rather than obstacles. Unlike science fiction, the construction of Ocean Spiral does not begin underwater, it begins on land. Inside shipyards where massive curved sections are fabricated, inspected, and tested under real-world conditions. Each module is designed to survive corrosion, pressure, and long-term exposure to saltwater before it ever reaches the ocean. Once validated, these structures are transported by specialized vessels to offshore sites where weather, waves, and timing dictate every operation. Using cranes and precision monitoring systems, individual sections are lowered into open water, guided into position by remotely operated vehicles equipped with cameras and alignment tools. Under the surface, automated clamps lock modules together while robotic arms perform welding and sealing tasks that human divers cannot safely execute at depth. With every connection, sensors activate to measure stress, vibration, and structural integrity in real time, ensuring the system behaves exactly as engineered. Construction proceeds vertically, one segment at a time, forming a growing link between surface and depth. Throughout the process, teams coordinate across ships and onshore control centers, responding constantly to changing ocean conditions. Even when systems are partially connected, they are tested cautiously, power flows, water channels, and data lines verified step by step. What emerges is not a finished city, but a structure in progressively incomplete, carefully monitored, and built only as fast as the ocean allows, before a single person could ever live above or below the ocean's surface. The Ocean Spiral must first prove that it can survive the sea itself. Every component is subjected to extreme testing, starting in wave laboratories where scaled models face typhoon-level forces, and continuing offshore where real ocean conditions confirm how energy dissipates beneath the surface. Structural systems are shaken by earthquake simulations compressed under repeated pressure cycles, and monitored for fatigue long before permanent deployment is considered. Buoyancy controls are tested to ensure the surface habitat can adapt dynamically to changing conditions, while internal safety systems are validated through full failure drills that simulate power loss, flooding, and communication breakdowns. Nothing is assumed to work automatically. Redundancy is built into every layer. At the same time, long-term monitoring tracks corrosion, microfractures, and material aging, revealing problems that only time can expose. Environmental safeguards are tested alongside structural ones, ensuring marine ecosystems remain protected. As development progresses, advanced risk analysis models then combine all of this data, identifying weak points and guiding design revisions before construction moves forward. These tests do not signal readiness for habitation. They define the threshold that must be crossed before it can even be considered. In an environment as unforgiving as the deep ocean, safety is not a feature, is the foundation for Japan. The Ocean Spiral is not an experiment, and access it is a response to reality. As an island nation with limited land, dense urban centers, and a rapidly aging population, Japan faces pressures that cannot be solved by building outward forever. Along its coastlines, cities have reached physical limits, while natural disasters continue to test the resilience of land-based infrastructure. Yet beyond those crowded shores lies one of Japan's greatest untapped assets, the ocean itself. With one of the largest maritime territories in the world, Japan possesses vast space beneath the surface space that is stable, insulated, and largely unaffected by the forces that disrupt life on land. Developing underwater infrastructure offers a way to relieve urban pressure, secure energy independence, and maintain functionality even during surface-level disasters. It also aligns with Japan's long-standing investment in precision engineering, robotics, and marine research, turning existing strengths into long-term strategic advantage. While other nations have imagined underwater cities as isolated experiments, Ocean Spiral is conceived as a system integrated, scalable, and sustainable. It is not about escaping the surface, but extending civilization into a domain where Japan is uniquely positioned to lead. In a future shaped by climate uncertainty and spatial limits, the question is no longer whether the ocean will be used, but who will learn to live there first. The Ocean Spiral does not end with a skyline or lights beneath the sea. It ends with a question. What exists today is not a city, but a design tested, debated, and carefully measured against the realities of the ocean. Its timelines remain projections, its costs estimates, and its future undecided. Yet the idea it represents is already real. As humanity faces rising seas, limited land, and growing uncertainty, the boundaries of where civilization can exist are being quietly redrawn. For centuries, we looked upward to mountains, to the sky, to space for our next frontier. Now, attention is turning downward, toward a vast environment that has always surrounded us, yet remained beyond reach. The ocean does not promise comfort, but it offers stability, space, and energy on a scale few other places can match. Whether Ocean Spiral is ever built will depend not on ambition alone, but on patience, responsibility, and collective choice. Because this is not just a question of engineering, it is a question of values. If we have the ability to live beneath the sea carefully, sustainably, and without harming the world around us, should we? And if we do not explore that possibility, what does that say about how we face the future?